So now we are going to discuss about machine learning in healthcare. Machine learning is a family of statistical and mathematical modeling techniques that uses a variety of approaches to automatically learn and improve the prediction of a target objective without explicit programming. These are the systems that improve their performance in a given task through exposure to experience or data. Machine learning may be divided into supervised, unsupervised, and reinforcement learning. Each of these approaches can address different needs. For the sake of simplicity, we will focus primarily on supervised learning. There is an input, some kind of processing, and an output. For example, y equals x square. In this case, the input is x and there is an output y. Or another example might be abnormality detection, where the input is an ECG and the output is a medical diagnosis. For both these examples, in between the input and the output, there is something that processes the input to produce the output. In first example, it is squaring the input x to arrive at the output y. In the ECG example, there is a visual analysis being performed on ECG leading to the output diagnosis. In both cases, the processing we are referring to is the condition that transforms the input into the output, and that's called a function. In a traditional computer programming approach, we deliberately write rules to process the inputs so that they produce the desired outputs by hand. This is why traditional computer programming approach is referred to as a rules-based approach. So if we were to write a program for the first example, the program would ask for an input x, then square the input and return the new output y. The function here is the part that squares the input. The same thing needs to happen if we want to take a traditional computer programming approach to the ECG example. But obviously the function here would be much more complicated than just simply squaring the input. In machine learning, and in particularly supervised learning approach, we don't know exactly how to process inputs to produce the right outputs. But we have a lot of data that links inputs to the known corresponding outputs. The program written in this approach learns and finds a function that can accurately map data inputs to the outputs. We can use this function to process new inputs and produce new outputs. In our example of ECG diagnosis, we explained how difficult it would be to write a function that would process ECG as input to accurately give a diagnosis as output. The inputs in this case are complex and vary from patient to patient. The function from input to output can be difficult to write. Very often we know the right answer or the output is supposed to be. If a cardiologist has already looked at the ECG or the input and recorded a diagnosis or the output, we have two parts to the equation. All we need to do is figure out the function that solves this input-output relationship. Supervised learning is the process through which program takes input-output pairs and learns the function that links them together. We call this supervised learning because we provide input and output pairs. We are supervising the model by providing it with right answers. The entity that undergoes supervised learning is commonly called a model because it represents or models the relationship between the inputs and the outputs. Learning this relationship means learning a function. A model is defined entirely by its parameters and the operations between them. The field of machine learning is largely dedicated to discovering algorithms and techniques for finding good values of parameters that allow model to match inputs closely with their corresponding outputs. Sometimes a model is called a function approximator, and this is because this is exactly what it does and approximates the function between the inputs and the outputs. Once the program learns a function that works well, we can use it in place of the software that would have been written by a traditional computer programming approach. We can take new inputs, put them through a learned function and produce new outputs. This is the ultimate goal of supervised learning. The program searches for and learns an accurate mapping function instead of pre-specifying it. In our ECG example, we would expect that with enough inputs or ECGs and enough outputs or diagnosis, the function can be learned by a model and we wouldn't have to explicitly program each step of the function by hand. The model would learn to read ECGs like a cardiologist. Because supervised learning relies on labels, the success of any supervised machine learning approach is dependent on the labels being correct. We call it supervised learning because we provide the input and the correct output labels to the machine learning model as a supervisor who teaches the learning algorithm. The machine learning model learns in a supervised way through many examples of inputs and output labels, how to eventually build a function that can accurately take new data that doesn't have any labels and reproduce labels accurately as output.